Welcome to Data Science 1, Probability. Handy probability rules. Okay, so you remember from the last video that we have E as an event that exists in a sample space S, and S contains all the possible outcomes of our experiment. We remember that the probability of the sample space is equal to 1, meaning that some event or outcome in there will occur. E union F is the union of events E and F, so it's what it is in either E or F, not exclusive or, could be in both. E intersect F is the intersection of the events E and F, so it has to be in both E and F. And we also remember that probability behaves like area. All right, so here's some rules that we might want to be able to use. Suppose we know the probability of E, and we want to know its complement. What's the probability of the complement? Well, if I know this, and I know the area of the box, then it's simple subtraction, right? You say, well, 1 is the area of the box, that's the probability of the sample space, and that's equal to E union E complement. That's equal to the sample space as well. So, because if I union those two together, I get S again, which is equal to the probability of E plus the probability of E complement. If I just simply move the probability of E to the other side over here, I get the probability of E complement is equal to 1 minus the probability of E. So let's look at a quick example. Suppose we know that the probability that my mobile phone has a service along my path to work is 0.97. So there's a dropout spots. What is the probability that my mobile phone won't have service on my path to work? So let E be the event that I have mobile service on my path to work, and I know this is equal to 0.97. The complement is I don't have mobile service. So somewhere along the way, it's going to drop out. So we can calculate it by the probability of E complement is equal to 1 minus the probability of E, which is 1 minus 0.97, which is equal to 0.03. Hence, there is a probability of about 3% that I don't have mobile service on the way to work. Okay, here's another rule that we could use. Unions. Suppose we know E, the probability of E, the probability of F, and the probability of the intersection, and we want to know the probability of the union. Well, if I know E, and I know all of F, well, that's too much. I've overcounted any outcomes that are in here, right? Because they're in both E and they're in F. And remember, we're thinking about this like counting. Well, whatever's in there has been counted twice. So what we need to do is extract this information from the middle so that we haven't overcounted it. So the probability of E union F is the probability of E plus the probability of F, and then we're going to subtract out the intersection because we've overcounted it. Now, let's look at an example. So football is a big deal at my Sports R Us sporting retailer. Corporate-wide, they have several groups that get together to watch football. Of their employees, they know that 12 support Manchester United, 19 support Chelsea, and 3 support both Manchester United and Chelsea. What is the probability that a randomly selected employee supports Manchester United or Chelsea? So it means they could have one or the other. So if I take this, it's both and it's or. So M is the event that the employee supports Manchester United. C be the event they support Chelsea. From the above information, we know this. Probability of Manchester is 0.12. The probability of Chelsea is 0.19. The probability of Manchester and Chelsea is 0.03. So the probability that they support at least one of them, which is what this is, Manchester or Chelsea, not exclusive. This is the rule we get. We're going to add the probability of M plus the probability of C minus their intersection, which is 0.12 plus 0.19 minus 0.03, and we get 0.28. All right, intersections. There's a very similar rule about the intersections because it's basically the same formula we had before, except these two are swapped. And algebraically, that works out just fine. So here we know the probability of E, we know the probability of F, and we know the probability of the union, and we want to know the probability of the intersection. So here we go. Javier is interested in selling 2 hair care products, brand A and brand B. He knows that the probability that a person finds brand A acceptable is about 40%, or 0.4. And the probability that a person finds brand B acceptable is 0.6. What is the probability that they find either brand A or brand B acceptable is 0.72. what is the probability that the first finds both brand A and brand B acceptable? Okay, and then we have this or, and we have this and. Okay, so this is telling us this is a union and this is an intersection. So brand A, 0.4, brand B, 0.6. Brand A union brand B is 0.45. So if we put this all together, we get 0.55. Okay, so about 55% would find both brand A and brand B acceptable. All right, so if you see here, we have developed 3 little rules here that can become handy when we're trying to deal with probabilities, and we'll come back to them here and there at different times. Now, the first one is used like all the time, so you should really get a handle on that one. But otherwise, we can learn some other rules, and we'll save those for the next video.